Welcome back, grade 12 seniors, and today's recording is lesson 5 in topic 1, and the title of the lesson is Reaction Spontaneity. Now, the first thing we would like to start with is define what is the meaning of a reaction is spontaneous. Okay, spontaneous means it happens alone. It happens alone. What things happen alone? If you leave a cup of hot tea in a room and you come after 1 hour, what will you find? You find it will be cold. This happens alone, so this is spontaneous. If you take an apple, okay, and you cut the apple into pieces, okay, and you leave it for, you come after 1 hour, how will you find the pieces of the apple? The pieces of the apple will be brown. This will happen alone, so this is spontaneous. If you leave iron in a place and you come after 1 year, you will find that it will rust. Also, this will happen alone, so this is spontaneous. So any spontaneous reaction means it happens alone. If you carry on ice cream in a hot day, what will happen? It will melt. This will happen alone. Also, this is spontaneous. So the first thing I want you to know is that a spontaneous reaction will happen alone. A non-spontaneous reaction will not happen alone. For example, if you want to bake a cake, if you leave it in the kitchen, will it bake? No, till you put it in the oven. So this is non-spontaneous. Okay, so certain things are spontaneous, means they happen alone. Non-spontaneous means they require energy to happen. Okay, the first thing we want to describe today is called entropy. Now, what is entropy? Entropy in brief, entropy is the measure of randomness. By randomness, I don't mean الفوضى in your room. Randomness means if the particles move more, they will make more randomness. If they move less, means they will make less randomness or less entropy. Okay? So entropy is the measure of randomness, or you can say also the measure of disorder. Now, where do you think the particles will move more and make randomness? In solid or in liquid or in gas? طبعا in gas. So in gas they will have the highest entropy, and then liquid is more than solid. Okay, now this is number 1. Number 2, if I take a spoon of solid salt, okay, this is solid salt, so solid, and I dissolve it in water. When it dissolves in water, it becomes aqueous. Where do you think the salt particles will move more, when they are solid or when they are aqueous? When they are aqueous. So aqueous have more entropy than solid. Okay, now if we have a small atom, for example He, and we have an O2. This one is made of 1 atom, and this one is made of 1 nitrogen and 2 oxygen. So this is 3 atoms. Who will make more randomness? طبعا 3 atoms. Okay, so I will say Sg is more than S, L is more than S solid. How do you read this one? We read this one as entropy of gas is more than entropy of liquid is more than entropy of solid, where entropy is the measure of randomness. Okay, طب for example, if you have H2O solid is becoming H2O liquid. This is ice is melting. Do you think here when I do this reaction, there will be increase in entropy or decrease in entropy? Okay, now how can we tell? Where do you think the particles will make more randomness, in solid or in liquid? طبعا in solid, the particles are very close to each other. They cannot move. In liquid, they have a little bit of spaces. So where do you think they will move more? طبعا in liquid. So as I go here, there will be more randomness, more entropy. So I will say here, this one will have more entropy, or delta S will be positive because more entropy. Now, if we say H2O gas is becoming H2O liquid. Okay, this is what happens in the clouds. In gas, the particles are too far. In liquid, they come closer to each other. So where do you think the particles will move more, in gas or in liquid? طبعا in gas. So as I go here, I will have less entropy. Less entropy means delta S is negative. Okay, so remember, whenever you are asked about entropy, entropy is the measure of randomness or disorder. Think of where particles move more. Do they move more in solid or liquid or gas? Gas, so they make more randomness in gas. In solid or in aqueous? In aqueous. One very important question, where do you think particles make more randomness? In aqueous or in gas? طبعا in gas. So the entropy of gas is more than the entropy of aqueous. Okay, type. Who makes more randomness, small particles or big particles? طبعا big particles. Okay, now let's try to do practice question. Okay, before we do the laws of thermodynamics, let's see this question. Now, we have to choose the substance with a smaller entropy, يعني less randomness, less disorder. Okay, SO2 liquid or solid, where do you think the particles move less? In solid, طبعا in the solid. Why? Because the entropy of solid is less than the entropy of the liquid. Now, Ki solid or aqueous? طبعا in solid, the particles are very close to each other. They cannot make randomness. In aqueous, they are separated and swimming in water. So where do you think they will move more? In aqueous? I want to choose the one with less randomness, so this will be the solid, because the entropy of the solid is less than the entropy of the aqueous. Now H2O liquid or solid? طبعا in solid they are very close to each other, they cannot make randomness. In liquid they have spaces, so the solid is less. And O2 gas or O2 gas? Notice here that both of them are gas particles. So we have to check which one is smaller and which one is larger. This one is made of 1 nitrogen, 2 oxygen, so this is 3 atoms. O2 is made of 2 atoms. So who makes less randomness? O2. Okay, now solid, NaCl or aqueous? طبعا in solid they cannot move. In aqueous they swim in water. So what do we choose? We choose the solid. Okay, CO2 gas or CO2 solid, who moves less? Solid. Okay, now let's go back to the page that we skipped and go through the questions. Okay, now first law of thermodynamics says energy cannot be created nor destroyed. The second law of thermodynamics says the disorder of the universe is increasing. disorder الفوضى دائما بتزيد. Okay, طيب. Third law of thermodynamics says the entropy of a crystal is 0. Crystal means the particles are arranged in order. They don't have any randomness. ما فيهم randomness. Crystal like diamond. Okay, they don't have randomness, so the entropy is 0. They don't have any entropy, they don't have any randomness. Now let me check this one for you. This one is, the sign should be like this because the gas is more than the liquid and the liquid is more than the solid. Now who have more entropy, gas or aqueous? طبعا gas have more entropy. Okay, now suppose that we have a reaction like this. Okay, let me copy this reaction. Okay, we have 2NH3 gas and we have here 2N2 plus 3H2 gas. Okay, and I want to know if I'm going through this reaction, does the entropy increase or decrease? Now, as we agreed before, we have to look at the states. This is gas, this is gas, this is gas. Oh my God, all of them have the same state. So how can I tell? Now, in this case, you have to count the number of moles of the reactants and the number of moles of the products. How many moles in the reactants do you have? 2 moles of gaseous reactants. Now here, how many moles I have? 2 plus 3. So this is 5 moles of gas. Who do you think will make more randomness? 2 or 5? طبعا 5. إذا هون أنا عندي more randomness or more disorder. So here I have more entropy. More entropy يعني delta S will be positive. I'm moving towards more entropy يعني delta S will be positive. Okay, let's do more practice questions. Now let's look at this. I have gas. So I cannot tell who will make more entropy, so I will count the moles. How many moles do I have here? 2. How many moles do I have in the products? 2 plus 1. So the total is 3. So who will make more randomness, 2 or 3? 3. So as I go here, more randomness. So the entropy is positive. Now this one is solid and gas becoming solid. هون عندي gas will make more randomness. If I move this way, less randomness because the solid particles will not move. So delta S will be negative. Okay, now hon gas is becoming solid. Where do you think more randomness will occur? طبعا بالgas. So as I go this way, there will be less randomness. Less يعني delta S is negative. Now here, gas مع gas, I cannot tell. So I look at the moles. Here I have 2 moles and here I have 3. As I go this way, more randomness. يعني delta S is positive. Now again, gas, 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 gas. So I cannot tell. So what do? I count the moles. 2 plus 3, 5. Now the products. 2 plus 2, 4. 5 to 4. Less moles يعني less randomness. يعني delta S is negative. Now liquid to solid. Where do you think the particles will move more in liquid? So as I go this way, there will be less randomness. يعني delta S is negative. Okay, try to hide these and check for your answers. Okay, pause the video and answer the questions by yourself. Before we were doing predicting the sign of delta S, is delta S positive or delta S negative? Now we will start how to calculate delta S. How to calculate delta S. Then you have two things to know. Either for delta S, predict the sign, and when I say predict, this means without calculation. And number two, I can calculate delta S in numbers. Okay? For example, if I have this question, this reaction, and it says predict the sign of delta S. This means tell me if delta S will be positive or if delta S will be negative. Predict means without calculation. Okay? طيب هلا let's look at the states. Gas, 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 gas. ما استفدنا. What should we do? We should check the moles. How many moles do you have in the reactants? 9 moles. How many moles do you have in the products? 4 plus 6. This is 10 moles. Okay, now I can tell who makes more randomness, 9 or 10? طبعا 10. So delta S will be positive. This is the way I predicted the sign without doing any calculation. Okay, now how do I calculate delta S? It's very easy. It's very similar to delta H. But delta S will be equal to S final minus S initial. What is the final? Final is products minus initial is reactants. Yeah, but let's look in this reaction. When the products NO, H2O. Be careful, NO should be multiplied by 4. يعني 210.8 ضرب 4. Now H2O should be multiplied by 6. يعني 188.8 ضرب 6. And then you find the entropy of the products. Minus. Now entropy of reactants. Where are the reactants? H3 times 4. So 192.8 times 4 plus O2 205.2 ضرب 5. Okay, يلا calculate the products alone, the reactants alone, minus them and find the entropy. And you will find at the end that the entropy is positive, same like what we predicted before. Okay, pause the video and check the answer. Okay, same thing here. Calculate the correct delta S for the reaction above. Before you look at this reaction, okay? Now, is this reaction endothermic or exothermic? When I say endothermic or exothermic, you have to look at the heat. Now, is the heat in the reactant side or in the product side? The heat is with the reactants. And when the heat is with the reactants, this means that the heat is absorbed. This means that it is endothermic. Okay, يعني delta H is positive. Now the question is the correct delta S. Can we predict the sign before we solve? Can we predict the sign? يعني to tell if delta S is positive or negative? Okay, first of all, we will look at the states. We have here gas and here gas and here gas. How many? Okay, so all of them are gases, so we will look at the moles. How many moles do we have here? 2. How many moles do we have here? 1 plus 3, this is 4. So who will make more randomness, 2 or 4? 4. So more entropy, so delta S will be positive. Yani the answer is either D or E. Now, how do I calculate delta S? Delta S is equal to S products minus S reactants. Now, the products N2 times 1 plus 3 times H2, which is this one. Now, the reactants are 2 times NH3, which means this one multiplied by 2. Okay, yalla, check and find the answer, and I will give you now the right answer. Pause the video and do the answer. Okay, now the answer will be, I think it will be 198.3. Okay, now I want to introduce for you a third term which is called Gibbs free energy, delta G. Now, delta G is called the free energy, and it is called the energy needed to do the work. This is the energy needed to do work. Okay, now remember that you have 3 terms so far. We have the enthalpy. Okay, enthalpy is the heat or delta H. It is defined as the energy that flows from hot objects to cold objects. Okay, and its unit is joules or kilojoules. بالfood we called it calorie or calorie. Okay, now the second term was the entropy. The symbol of the entropy was delta S. Its definition is the measure of randomness. Measure of randomness, and its unit is joules over Kelvin. Now the last term is the Gibbs free energy. Its unit is delta G, and it is the energy needed to do work. وبما إنها energy is its unit is joules or kilojoules. Okay, so you have 3 terms, don't confuse the 3 together. We have free energy, we have the entropy, and we have the enthalpy. Now, how do we calculate Gibbs free energy? Gibbs free energy is calculated by the rule delta G equal delta H minus T delta S. Now, what is delta H? Delta H is the enthalpy. What is T? This T is not time, be careful. This is the temperature. What is delta S? Delta S is the entropy. Now, very important thing you have to be careful about is the units. Now, delta H should be in joules. T will be in Kelvin. Delta S will be in joules over Kelvin. Now, when we simplify this one and this one, Kelvin and Kelvin will cancel, then we will have joules. Joules minus joules, this will be joules. هلا delta H دائما will be given to you in kilojoules. So what will you do to change it to joules? We will multiply it by 1000 flatten. If the temperature was given in Celsius, so you will add to it 273 to make it Kelvin. Okay, these two things, be careful for them. The temperature should be in Kelvin. If they give it to you in Celsius, add 273. Delta H should be in joules. If they give it to you in kilojoules, multiply it by 1000. Okay, yalla, let's do practice. Okay, before we do practice, you know that enthalpy could be positive and could be negative. If delta H is positive, I call the reaction endothermic. If delta H is negative, I call the reaction exothermic. Now entropy, if the entropy is positive, this means there is more disorder or randomness. If delta S is negative, this means there is less disorder or randomness. Delta G is positive. This means the reaction needs energy to do work. And if it is negative, means the reaction does not need energy to do work. Does not need energy to do work. And if it does not need energy to do work, this means that the reaction is spontaneous. Be careful. If the reaction needs energy to do the work, means the work will not be done alone. I say the reaction is non-spontaneous. If the reaction does not need energy to do the work, means the reaction is spontaneous. Okay, so in this case, how do we calculate delta G? Delta G equal delta H minus T delta S. Let me give you an example on a work in a reaction that does not need energy to do work. For example, if you are at the top of the hill, you put a ball at the top of the hill and the hill is going down. The ball will roll by itself. This means that no energy is needed to do the work. No energy is needed to do work. This means that this is spontaneous. Spontaneous يعني delta G will be negative. Okay, but the opposite is if the ball is here at the bottom and I want to send the ball up. This one will not go alone. This one needs energy to go up. So when it needs energy, this means delta G is positive. This means it is non-spontaneous. Okay, so be careful for the sign of delta G. Before we do the signs, let's do a question on calculating delta G. Calculate delta G for the following reaction, and he gave you delta H and delta S. Now pause the video and try to solve it by yourselves. I want you to remember two things. Number one, delta G equal delta H minus T delta S. Delta H should be in joules. Here it's given in kilojoules, so you need to multiply it by 12. Okay, the temperature should be in Kelvin. Here they gave it to you in Celsius, so you need to add to it 273. And delta S is 40, so you don't need to change it. Yeah, let's put the numbers and try to find delta G. Okay. When you finish, also do this one. You have delta H, you have the temperature, and you have delta S, and you need to find the Gibbs free energy. Delta G equal delta H minus T delta S. Delta H is minus 4.8. طبعا it's in kilojoules, so I will multiply it by 12. Now the temperature is 250. I need to change it to Kelvin. Now delta S is 60, and then you find the answer, and the answer will be in joules. Okay, now before we continue, let me tell you about these signs. How can you know these signs? How can you memorize these signs? Now, the sign of delta G, as you know, delta G is equal to delta H minus T delta S. So the sign of delta G is dependent on delta H and delta S. Okay, what are the options? You might have both of them a negative, or both of them positive, delta H positive, delta S negative, delta H negative, and delta S positive. So these are the four different combinations that you might get. If delta H is negative and delta S is negative, you put negative and negative. You will say the reaction is spontaneous at low temperature only. If both of them are positive, this means the reaction is spontaneous at high temperature only. إذا نتذكروا minus minus means low temperature. Plus plus means high temperature. Now, if one of them is plus, one of them is minus, delta G will be my name. What is my name? My name is Hanan. So delta G will be my name. It will be Hanan. So it will be positive. Also here, this is negative, this is positive. Delta G will be me, delta H. So it will be the same like my name, negative. What does it mean if delta G is positive? Means the reaction is never spontaneous or non-spontaneous because it needs energy to do the work. What if it was negative? It is spontaneous دائما وأبدا. Okay, إذن remember, both of them negative, spontaneous at low temperature only. Both of them positive, spontaneous at high temperature only. Plus minus, delta G will be my name. Plus. Minus plus, also delta G will be my name. Okay, now try to do this table by yourselves. Yalla, you have delta H, delta S, delta G. Okay, plus plus شو يعني minus minus شو يعني minus plus plus minus. Okay, try to put delta G. Pause the video and do delta G. Okay, now let's do practice on this table. How does it come to you in the exam? Let's look at this table. Okay, this table shows 3 different reactions. Okay, now enthalpy is given. Remember, what is enthalpy? Enthalpy is delta H. Here delta H is positive, here delta H is negative, and here delta H is negative. Now we want to know which one is entropy, enthalpy, all these questions. So I want you to do 2 things. First thing, I want you to tell me what is delta S and conclude delta G. Yellow, we need to know if delta S is positive or negative in each one. Yellow, like we did before. Here, liquid to gas. Where do you think there will be more randomness? In gas, so delta S is positive. Here, gas to liquid. Where there will be more, as we go here, there will be more randomness or less? Less, يعني negative. Okay, now here all of them are gases, so I cannot tell. What do? I count the moles. 2 plus 13, 15. 8 plus 10, 18. So as I go this way, more moles, more randomness, so positive. Now I know the sign of delta S and delta H, I can tell delta G. Both of them positive بيكون spontaneous at high temperature. Both of them negative بيكون spontaneous at low temperature. Minus مع plus, so delta G will be me, my name, Hanan, minus. Minus يعني spontaneous. هاي يعني spontaneous at any temperature, okay? يلا, let's see the questions. Which process shows a decrease in entropy? طبعا entropy يعني delta S و decrease يعني minus. This will be process 2 only. Which process shows an increase in their entropy? Entropy يعني delta S, increase يعني positive. So we will look here, we have 2 processes اللي هن 1 و 3. Which process is spontaneous at all temperatures? يعني دائما spontaneous, this process, which is 3. Which spontaneous is spontaneous only at high temperature? At high temperature الأولى, process 1. Okay, now I'll give you another question, you try it by yourselves. Okay, same thing here. I have to tell me what is the sign of delta H, what is the sign of delta S, and what is the sign of delta G. Okay, here from gas to liquid, the particles will show less randomness, so delta S will be negative. Okay, here from gas to liquid, the particles will show less disorder and less randomness, so it will be negative. Here all of them are gases, so we will count the number of moles. Here we have 3 moles, so we cannot tell. Okay, here in this case, they will have to give you the values of the entropy of each of these, and then you do the calculation for delta S. Okay, minus minus, this means it is spontaneous at low temperature. Plus minus, delta G will be me, so it will be positive. Positive يعني never spontaneous. Okay, now the question, which of the following is never spontaneous? طبعا the answer is process. Okay, يلا do this. Which of the following process is spontaneous at all temperatures? Same what we did. Put the signs of delta H, delta S, and then put the signs of delta G. Delta H is from here. Okay, delta S, liquid to gas. This is positive. Okay, we have here 3 moles of gas is becoming liquid, so this is negative. And here we have 15 and 18, more randomness, and this is positive. Now plus plus, this one will be spontaneous at high temperature. Minus minus means spontaneous at low temperature. Minus plus, so this one will be minus, so this will be spontaneous. Now the question, which of the following process is spontaneous at all temperatures? طبعا this will be process 3. The decomposition of sodium chloride into its own elements is not spontaneous. When we say not spontaneous, means delta G is positive. When is delta G positive? Delta S, delta H. Positive means delta H is positive and delta S is negative. Okay? Because if they are different, delta G will be my name. So delta H is positive, delta S is negative, and delta G is positive. So the answer is C. Positive, negative, positive. طيب. Now how do we calculate delta G? You have this question. Delta G, as we said, delta H minus T delta S. Delta H انتبهوا should change it to joules, multiply by 1000. The temperature should change it to Kelvin at 273. Okay, solve. Pause the video and solve. طيب هلا we have the reaction. This reaction is spontaneous at all temperatures. يعني دائما spontaneous. يعني delta G is negative. When is delta G negative? Delta H, delta S. Negative means delta H is negative and delta S is positive. يلا choose the correct answer. Okay. يلا. Now you have this question plus plus. Both of them are positive. This means that delta G is spontaneous at high temperature. So it is this is the answer at high temperature. Okay, now another way to calculate delta G is G products minus G reactants. This is the same rule we used with delta H. قلنا نحن delta H products minus H reactants. Delta S products minus S reactants. Delta G products minus G reactants. Okay, so the same rule will apply دائما whenever you have delta final minus initial. Okay, now this is a substance changed from phase M to phase R when heat is added. Okay, now this is solid and this is liquid. What about delta S? From solid to liquid, the entropy is positive. Okay, what about delta H? When you want to melt ice, this is endothermic. Okay, now this reaction is spontaneous at high temperature. Remember دائما whenever we have phase change, يعني change from solid to liquid, بتكون الدلتا G is equal to 0. يعني delta H minus T delta S is equal to 0. Move this to the other side, you will get delta H equal T delta S. Okay, so delta G is equal to 0. R have greater entropy, there is equilibrium, and all of the above are correct. Okay, same thing here we do G of the products minus G of the reactants. Okay, remember CO2 is here, H2O should be multiplied by 2, O3 should be multiplied by 4, O2 multiplied by 8 is already 0 because we cannot make it. CH4 is minus 50. Yalla, pause the video and do the question. Okay, you have this question, which reaction is spontaneous at all temperatures like we did before. Let's do delta H, delta S, and delta G. Okay, here we have 9 moles and here we have 10 moles, so the entropy is positive. Here we have 3 moles and here we have 2 moles, so this is negative. Here we have solid becoming gas, so this is more randomness. The gas particles will move more, so this is positive. Now delta G plus و minus بتكون نفسي minus بتكون spontaneous at low temperature, plus بتكون spontaneous at high temperature. Which reaction is spontaneous at all temperatures means delta G is negative. It does not need energy, so X. Consider the reaction, calculate delta G. طبعا delta G equal delta H minus T delta S. Okay, for this reaction, Y. Delta H is minus 120 kilojoules, so I will say minus 120 ضرب 1000. minus the temperature is 298. It's already given in Kelvin, Banat. You don't have to change it, Shabab. Okay, delta S is minus 150. Okay, and then you find the answer. Is the answer spontaneous or non-spontaneous? If delta G was positive, this means it is non-spontaneous because we need energy to do the work. If delta G was negative, this means it is spontaneous. So check your answer here and then you decide this part. Okay, now this is the last question in your practice sheet. You have delta G of each of these. Now, first question, does the reaction show a decrease or increase in entropy? طبعا we have to say the states. Gas becoming solid, liquid. Where do you think the particles move more? Here. So as I go this way, there will be less randomness. Less randomness means delta S is negative. Calculate delta G. Delta G will be G products minus G reactants. Products B2O3, H2O انتبهوا you multiply it by 3. Okay, now the reactance is B2H6. Well, O2 is not given because this is 0. We cannot make it. Now, is the reaction spontaneous or non-spontaneous? شوفوا sign of delta G. If it's positive, بيكون non-spontaneous. If it is negative, بيكون spontaneous. Now, this is the end of your lesson 5. I hope the video was beneficial for you and you learned